What is going on, everybody? Got another problem here for you. So we've got a double integral here. We're going from 3 to 9, 0 to 6, x times y times e raised to the x plus y dy dx. Now, this may look like a tough problem, but really it's not. So the key to this one, to make it easy to work, is to rewrite this thing like this: x, y. Now, remember, there is a property in algebra that says this. So if you're multiplying like bases, you add the exponents. And you can see this e to the x plus y, that's what we have over here. So what we're going to do is we're going to write this as e to the x times e to the y dy dx. All right, and then we have a property with double integrals. See how we can get the x and the e to the x together, and then that's times y and e to the y. So this we can write as 3 to 9. Now, remember, this inside part here, this right here, we're integrating with respect to y. So the bounds here, 0 to 6, that's for the y, and the bounds 3 to 9, that's for x. So this is going to be 3 to 9, let me change colors back. That's going to be x e to the x dx times the integral 0 to 6 y e to the y dy. So we can split it up like that because we can get the x terms together, we can get the y terms together, and they're multiplied, so we can multiply those two integrals together. So now all we're going to do is take each integral, integrate it, and then multiply the results together. So let's just take this, let's take 3 to 9 x e to the x dx, and let's just integrate this one. So here I'm going to let u equal x, dv equal e to the x. So what am I doing here? E to the x dx. So what am I doing? Integration by parts. And so we've got du, so we got du equals dx, v equals e to the x. So this is going to be x e to the x from 3 to 9 minus the integral 3 to 9 e to the x dx. And so this is going to be x e to the x from 3 to 9 minus, and then when I integrate this, that's e to the x 3 to 9. And so that's 9 e to the 9 minus 3 e cubed minus e to the 9th minus e cubed. And so you can see I've got 9 e to the 9 minus 1 e to the 9. That's going to be 8 e to the 9th, and then negative 3 minus negative 1, like terms. So that's going to be negative 3 plus 1. So that's going to be minus 2e cubed. All right. And, you know, you can plug this into your calculator. That's fine. I mean, I've already plugged it in, but I won't. Of course, I'm not going to do it on the screen. So, and then we've got 0 to 6 y e to the y dy. All right, so now same thing here. Look, it's the same thing. Integration by parts. So I'm going to let u equal y, dv equal e to the y dy. So du is equal to dy. V is e to the y. And so I get y e to the y from 0 to 6 minus, that's going to be integral e to the y dy from 0 to 6. And so that's y e to the y 0 to 6 minus then the integral antiderivative of that is e to the y, and that's 0 to 6. So I get 6 times e to the 6 minus 0 times e to the 0 minus, and then e to the 6 minus e to the 0. And so this term goes to 0. That's 6e to the 6 minus e to the 6. That's going to be 5e to the 6. And then that's just 1, so that's plus 1. And so my answer to this, let me just rewrite the integral down again. 0 to 6, what was it? xy e to the x plus y dy dx. So that's just equal to this integral times this one. And so this is what we got here. So that's 8e to the 9 minus 2e cubed times 5e to the 6 plus 1. And I'll leave that to you to plug into your calculator, but there you have it. That's your answer. That's how you work that problem. So you can see it. When you first look at it, it looks, that looks like a pretty tough problem, but really it's not. You know that rule that you can split them up like that, and then it's just a simple integration by parts here. All right, so I hope that video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.